Welcome. In this video I'm going to show you 6 different examples of how we can go about simplifying algebraic fractions that require some factorization before they can be simplified. Factorization being the process of rewriting expressions in their most compact form possible. Now, jumping straight into it, we look at example 1 and we see we have 3a minus 9 all over 3. Now with this we could go straight ahead and we say that 3 and 3 are divisible and 9 and 3 are divisible, so therefore the answer is going to be a minus 3. But that's not very intuitive to seeing everything that's going on there. Rather, what we can do is we can practice the simplification process using factorization. So factorization. Now, doing that, we look at our numerator and we ask ourselves, how can we factorize 3a minus 9 such that it's going to be useful with a denominator of 3? And what you can say is, well, if we break 3a minus 3 times 3 into its factors like that, what we see is that there's a common 3 here and a common 3 here. So what I'm going to do is go ahead and write 3, then in brackets I'm going to write a take 3, like so, and that's all over 3. Now we can go ahead and we highlight our 3 here and our 3 here. They're going to cancel out, and that's going to leave us with a over 3 all over 1, and that simplifies down to a take 3. So that, or what we've done in the first 3 lines here, is explicitly show how we can go from 3a minus 9 all over 3 down to a minus 3. Now if you're proficient enough with this technique and you can see visually that the answer is going to be a take 3, then you can go ahead and just jump past the first 3 steps that I've shown and go straight to the answer. That's totally fine. Now example 2, we have 4a plus 12 all over 8. So again, this is an example where we could just jump straight to the answer, but it's not always going to give us the nicest looking result. Rather, we're better off doing some factorization first. So what we're going to do is we'll factorize the numerator, and we're going to say, well, what's common between 4a and 12? So we go 2 times a plus 2 times 2 times 3. So the factors of the numerator there. And then we have a 2 times 2. Alright, factorizing the numerator. We have a common 2, 2, 2, 2. So what we're going to get is 2 times 2. Then what's left behind is a plus 3. Then downstairs we've still got the 2 times. Now I could simply cancel out the 2's here and the 2's here, but we'll put it all together such that it's a bit cleaner. So we'll go 4a plus 3, then we'll go 4 times 2, and then we'll highlight our 4's and we'll get rid of them. So we're going to get a plus 3 all over 2, like so. And you might ask yourselves, where did the brackets go? And we can simply say they're implied because there's nothing multiplying the a plus 3, so we can leave them off. So that's example 2. Now going down to example 3. This one looks a little bit trickier, and the reason it looks trickier is because we don't have any numbers here. Rather, we only have variables. So we've got ab plus ac all over b plus c. And what we want to do is be able to represent this in its simplest form. So what I'm going to do is I'm going to try and simplify the numerator again. And I'm going to write it as a times b plus a times c. And that's all over b plus c. Now I'm going to ask myself, what is common between the 2 terms in the numerator? And we have a common a and a common a. Therefore, we can write a, then we can open up some new brackets, and we ask ourselves, what do we leave behind? Well, we leave behind the b, and we leave behind the c. If we expand this bracket out, we're going to get ab plus ac, But if we leave it simplified, it's a multiplied by b plus c. Then downstairs, we've got another b plus c. Looking at this, we ask what's common between the numerator and denominator. Well, there's a bc upstairs and a bc downstairs. So what we can do is remove them. So we're going to get a over 1, and therefore the simplification of ab plus ac all over bc is simply a. That's example 3. Example 4, 6x squared minus 6xy all over 3x minus 3y. Now it's starting to get a little bit more complicated. So again, let's first start off by factorizing the numerator. And we have a 6x times x. And then, actually I'll change the color because that's a little bit hard to see. 6 times x times x. Got a 6 times x times y. And this is all over 3 times x, take 3 times y. Now we ask ourselves, purely looking at the numerator, what's common? Well, there's a 6 here and a 6 here. And it's a 6 times x and a 6 times x. And that's all that's common between the two. So we'll go 6, open up some brackets, and we'll look at what's left. We've got an x minus y, and that's all over 3 times x minus 3 times y. Okay, now let's turn our attention to the denominator. We've got a 3 times an x and a 3 times a y, so we ask ourselves what's common. Well, there's a 3 here. So let's take these guys out. So upstairs we still have the 6x. Downstairs we have the 3x. Alright, first step is let's deal with these x take y's. So here and here. They're common, so we say goodbye. So we go 6x over 3x. They're gone. Alright, now let's deal with the rest. So we've got x here and an x here. Let's cancel them out. So we're going to be left with a 6 over 3. And we know 6 over 3, well, that's going to simplify it down to 2. So quite a bit going on here. But we simply follow the steps and we come out at the final solution. Alright, moving on. Example 5. Let's get some more space. There we go. Example 5, we have 6a take 6b all over b minus a. Alright, so let's go for some simplification again of the numerator. So we're going to take out a common 6 and we'll be left with an a minus b. Then downstairs we have a... So what we've got here is, well, we've got a problem. This isn't going to work out. We might initially see the a's and the b's and say they cancel, but it's not quite going to work yet. Rather, we have to do some tricky or some clever manipulation. So we'll keep the numerator as the same, a minus b. Let's shuffle the minus a up front plus the b. Let's do a tricky manipulation, and we're going to multiply the top and the bottom by a -1, like so. What that's going to look like is the 6 will become a -6, then a minus b. Then downstairs, the a is going to become a positive a, and the b is going to become a negative b. So therefore, put some brackets there. What we've got is a double up, like so. Therefore, our final result is going to be -6 over 1, and that's simply -6. So, key thing of what we did here was we added the -1 over 1, and -1 over 1 is simply just equal to 1, so that's why we're allowed to get away with that. Next one, let's look at something a little bit more tricky. X y squared minus xy all over 1 minus x. Let's see if we can simplify this. So firstly, we'll factorize the numerator, and the factors of the numerator are going to be x, y, and then we're going to have left behind y take 1 Then downstairs we've got 1 take y. Now let's multiply both the numerator and denominator by 1, like so, and we'll go from it being just 1 to, we'll turn it into a times negative 1 over 1. So minus 1 over 1 is the same as writing 1. Alright? Now, because we're multiplying the top, that's going to become negative xy. Y take 1. Then downstairs, that's going to become y minus 1. Then we're dealing with double up here. So this, and therefore our final result is going to be minus x, y.